Hello everyone, welcome back to Bytes of CSC. So this is going to be a hands-on tutorial on lists in Python. So now list is literally a list, that is a collection of elements. So if I have to give you an example of a list, so this is a list, and also uh, this is also another list. Now up till this you might say that then list is actually an array. So yes, of course list is an array, but lists in Python is even more than an array. So now if I have to show you that, let me mention another, or let me create another list. And now this list looks like, so this is a valid list in Python. And just wait for one more thing. This is also a valid list. Now these two syntaxes clearly separates, or these two lists clearly separate list from an array. Now essentially in array contained all elements of same data type. But see, in this case, these two are strings, this is an integer and this is a float variable, and still this is legal list in Python. And this is more bizarre. Now these are some elements which are placed in one dimension, and this element, if you consider this a list, you might say that this is a sublist or a nested list inside a list. Now this element are actually a 2D element, and you can just like jumble up this 1D and 2D together in Python lists. So what happened in array was, if it is a two-dimensional array, all the elements will be placed in two dimensions. But here, some of the elements are placed in second dimension or two dimension, but these elements are essentially one dimension. Now list is a mutable data type, like you can actually manipulate the list in any possible manner. We'll get to that, but before that, so now list is a data structure which is mutable in Python, till now what we have learned. And if you have to mention a list, or if you have to let Python understand that this is a list kind of variable, you will be using these square braces, and each element is separated from the other using a comma. And of course you can mention a blank list, say list blank. So if you have to declare a variable beforehand and you want Python to understand that this is a list kind of variable, because in Python, unlike C, C++, you do not mention the data type. This is implicitly understood by Python. So in order to declare a blank list, you will just use these two braces and leave it blank. So Python knows that this is a list type of a data, like this variable is supposed to contain a list kind of data. So now let me go through the different operations on a list. So first let me mention about the insert operation. Now you can insert at the beginning, at the beginning of a list, or you can insert at a particular index position, and lastly you can add a collection of elements to the end of a list. Now if you have to sorry, by mistake, it was my mistake, insert at the end actually, sorry. So if you have to insert at the end of the list, you will use the append keyword, where the syntax is like, first goes the list variable, that's my list variable, then you use a dot operator, and then you mention this append keyword, and inside the braces you will be adding the element you like to add to your list. Now this can be a string. If it is a string, you have to use quotes. If it is a integer or float, well, you just write the element. If you have to insert at a particular position, my list where, then you add a dot, and now you have to use the insert keyword, and inside the insert keyword, first you will mention the index number where you would like to add the element, and then the value. This is the syntax of inserting at a particular index position. Now if you like to add a collection of elements, say a list, to the end of a list, so you will need to use this my list variable dot again, and then you will use this extend keyword, and you will add the list that is to be added. So now let's check these three out. Let me add at the end of this list 1. Let me just use this keyword append, or this value append, and now your list 1 looks like this. See, this was the original list 1 containing 89, 55 and 99, and now it contains this keyword, this value append. Now let me insert at position, say the index number 1. So now here index number 1 contains, now in Python indexing starts from 0. So this is index number 0, this is 1, this is 2 and this is 3. So at index number 1, the element 55 is present, and now let me append list 1 dot append. Now never mention or never use the variable list as your variable name for a list, because list is a reserved variable in Python, and list is also used to actually enlist a collection of elements or like that. I will not be using that syntax in this lecture. I will be doing it another lecture. So now, okay, sorry. So I wanted to add an element at index position number 1. So that will use the keyword insert. And now goes the index position, that is 1. And let me add inserted to it, and now your list 1 looks like this. So what happens here is your there was an element at position number 1, or index number 1 rather, and those elements, every element from that element till the end, it gets pushed to the right, that is one position. The index value of the elements gets increased by 1. So previously it was index number 1, now it becomes index number 2. Similarly, if you would like to change the value at this index, okay, no, sorry, let me come to that modification part later. We are left with extension of the list. Now let me just add to this list 1 list number 2. So now your list 1 looks like this. So your list 2 was this, A, H, J and IO, and now your list 1 has these 3 elements just added at the end of the list. So this was the end of the list where we had appended this element append at the end, and now it contains the elements of the list 1. Just imagine, it saves so many lines of codes. That if you had to add list 2 elements to list 1 in traditional way, what you had to do was you had to use a for loop and then loop through the variables and use append. Say if I have to show you that, say let me try to add list 3 to list 1. So now let me for I in range length of list 3 list 1 dot append list 3 I. And now your list 1 looks like this. So this was your list 3, A, list 8 and 8.9. So see these 2 lines of codes, and of course list 1 dot append, find the index, whatever. So these 2 lines of codes are actually replaced by this one line. So that's a very easy thing, right? Now next let us see that how you would remove or delete element from your list. So now let's go through the delete operation. So first of all, you can delete the last element, and also you can delete a particular element. Now when you like to delete the last element, you will be using the pop keyword, and before pop you will use a dot, and before that dot you will be using your list variable name, and this is done using the remove keyword. So similarly, my list where dot remove, and now you have to mention the element you like to remove. So now let's check these out. So this is your list 1. So when you use pop, it will delete the element from this position and it will return the element. So if I now use list 1 dot pop, it returns this element, and if you go through list 1, the 8.9 is nowhere to be seen. And say if you like to you would like to delete this append keyword from here, so you would use this remove keyword, and now this returns nothing. Like if it can successfully remove the element, it returns nothing. Now you have to go through list 1 and see this append keyword no longer exists. Now what if your element contains this append, say if you're trying to remove an element that occurs more than once in a list. Say for example, let me insert an element at the end. Say let me try to delete this 55. So let me append 55 at the end of this list. So now your list 1 is this, and now let me try to remove 55. So list 1 dot remove 55. Now that is being removed, and now let me see. So there was a 55 at this position, that is index number 0, 1, 2, and there was also 55 at the last index position. So at 0, 1, 2, 55 no longer exists. So we have 99 here. but at the last position 55 still exists. So whenever you are using the remove keyword, it will scan the list elements from left to right, and whenever it finds the first occurrence of that value, it will delete and it will return. So that was all about the deletion in list elements. Now you can also change particular elements. Oh, and one more thing, say if you like to remove all the elements from your list, you just want to leave your element as a blank list. So let me just which one shall I remove? Okay, let me remove all the elements of list 3. So if you like to remove all the elements, you will be using the clear keyword. So now list 3 was this, and now if you use list 3 dot clear, and now if you like to see what your list 3 looks like, it contains no element at all. It is just a blank list. It still exists, list 3 exists, but this remains as a blank list. Now we can also modify parts of your list. Say for example, I would like to change this inserted keyword, and let me just add something else to that. So in order to modify a particular element, you have to access the element using the index number. So this is index number 1. So now list 1 dot list 1, and now index number 1 is equals to modification, say. So now this inserted is changed to modification. Now let me see what your list 1 contains. So instead of inserted, it contains modification. Now this list traversal in fact is very important, and let me just show you some important points regarding this list traversal, which will also be used in list slicing. Maybe you just cut out a part of your list and you stored that in another variable and so on. So let me show you that traversal. So first of all, if you do something like this, if you just mention an integer, an index number here, say index number 3, it will give you back the element at this position. But say if you write something like this, list 1 3, then you add a colon, and then you say write 7, it gives you, so this is your list 1, okay, 3 to 7, it gives you A, HJ, IO, A. So what is happening here is, just a moment, yeah. So this is something like list variable. So there is a index, say that index number be B, and there be another integer index, let that be E. This means part of the list where from index number 3, index number B to index number E minus 1 will be chosen. So here what happens is, when I mention 3 colon 7, so your B is 3 and your E is 7 here. So that means the part of the list variable, in the case this list variable is list 1, from index number 3 to index number 7 minus 1 to be selected. So here from 3 to 7 minus 1, that is 6, is selected. So let me check what are the indices that are selected here. So this is your 0, 1, 2, 3. So index number 3 is A, and you will and your index number 3, 4, 5, 6 is this A. So now here you see index number 3, 4, 5 and 6 are selected. If I had mentioned something like, say, list where I mention the B, I put a colon, I do nothing else, then part of the list where from index B to last element will be selected. So let's try it out. List 1. So I mention 3, I leave it blank, and now this was your list 1. This is index number 3. So from here till 55, all elements are to be selected, and see, all the elements are being selected. And there is also another syntax which might be like where you put list where, then you leave your B index as blank, you just add a colon, and then you add index number E. So this means that part of the list where from beginning to index E minus 1 to be chosen. So let me try that out. Say we try with the same list 1, and we consider all the elements till say 8. And now you see this index number 0 is chosen, 1 is chosen, 2 is chosen, 3 is chosen, 4, 5, 6, 7. That is 8 minus 1, that is 7 are chosen. And you have another kind of what shall I say, syntax, which is also, you should know that. That is, say somebody just says that somebody just writes something like this, list where you put just one colon, then the entire list is to be selected. So if I do something like this, the entire list is chosen. And next, if I write something like this, I put the first colon, I leave it blank, and I put another colon, and now I add another integer 2. Now let me show you what happens here. Let me do the same exact thing using list 1. I put 2 colons and I add this 2, and now see, every alternate element is chosen. Now this 2 means that you will choose the second element from the current element. So when 89 was chosen, this 2 said that you will choose the second element from 89. So this is the first element modification, this was not chosen. 99 was chosen, and now at this point 99, the second element from 99, that is 8j, was chosen. Now a second element from 8j, that is A, was chosen. Second element from A, that is 9, was chosen. And second element from 9 was to be chosen, and since there is no other element at the at 2 positions away from 9, so the list display ends over here. Okay. Now an interesting thing is that Python also negative indexing is also legal in Python. So what happens in negative indexing is, if I do something like this, list 1 minus 1. See, the last element gets chosen. So negative indexing starts from your right hand side and it decreases up till here. So this is minus 1, this is minus 2, this is minus 3, minus 4, minus 5, minus 6. Let me show you. List 1 minus 6, sorry, minus 6. And see, that's 8j. So this is how the negative indexing works. So I will also mention something. This is all for you to take a note. So list where, say this is your index I. Here, if I is positive, then elements chosen from left to right, and if your I is negative, then element chosen from right to left. Now let me show you another interesting thing. If I do something like this, sorry, list 1, I put a colon, I put another colon, and this step value, as I mentioned, that to be minus 1. So this, what happens here is your list gets reversed. This was your original list, list 1, and now see, this is your same list in the reverse order. So it does not actually change your list 1. Your list 1 still is this. If you want to reverse your list and store that in another variable, you can do that. If you used list rev equals to this, your list rev is this. But if you like to reverse the original list, say if I like to reverse the original list 1, you will be using the reverse keyword. Now if you look at list 1, your list 1 looks like this. So reverse is done using, reverse is used to reverse the list. Similarly, if you would like to sort a list, you can use the sort keyword. But if you try to sort your list 1, this will throw an error, because this contains both string variables and integer variables, and obviously this is not supported between instances of string and int. So this sort can be used only if your list is like an array. For example, if you if I like to sort, say let me sort list 2. So list 2 was this, and now list 2 dot sort. Now your list 2 looks like, oh sorry, your list 2 was already sorted. 1 minute, let me just append an element and show you. Let me append bat. List 2 looks like this. Now let me sort this list 2 again, and now let me show you list 2. So your list 2 is sorted in this order. So this was all you could do with your list elements. Okay, you can also even find, say you are looking for the index number of a particular element of in your list. So that can be done using the index keyword. So list 1 dot index, let me find out, okay, let me just show you list 1 one more time. and also I'll show myself. Okay, list1 dot index um, list, and this returns an integer which is equivalent to the index number of this list. So this list element was present at index position 0, 1, 2, and it mentions that this is at the index position 2. Now let me say you would like to see that how many times a particular element occurs in a list, and that is done using the count keyword. So list1 dot count, say I'm trying to count the number of A's, so that gives me 2. Now what if you try to use this list1 dot index and the element does not or the element is not present in the list? Say I'm trying to find out 90. Yes, 90 is not present. So now this throws an error. So Python does not handle the exception. So if you are trying to use this, you will need to add your own exception handling try except loop. And say I try the same thing with the count variable. Maybe I'm trying to find the count of this element 90. Now this is very beautifully handled. It says that the count is 0, that is the element is not present in the list. So it is a safe way to use count, but index is not very safe. But of course index and count, they are two different functions and they return different values. This gives you the number of times this element is present, and this returns you the index position at which this element occurs. So now another function that is also present in list is a copy function. Say now you like to make a copy of this list and you are trying to you're trying to save that copy in another variable. Say that be list copy, and this is simple. You just use the copy keyword, and now list copy contains all the elements of list 1. But this is somewhat weird. I mean, why did we actually had this copy keyword? See, in Python or in actually any language, say A is a number 78 and you want B to be same as A. So you will write B equals to A, and then you find that the value of B is 78. So if this is legal, so is this illegal when you're using list? Let me find that out. Let me list assign. Let this be a variable, and I add I use the same syntax like B equals to A in here. So now, so it does not throw any error. So technically this is a legal statement. Now let me look at the elements of list assign, and this is same as the elements of your list 1 variable. This was your list 1. These two are the same. But then why did we need this copy function here? Now let me show you why did we need it. Why did we need that? So now coming back to this point, now let me change the value of A. Let me change the value of A to 99. And now let me check the value of B, and B is still 78. Why? Because A, when the value of A was 78, B was assigned this value, and now A contains a different value, but B, of course, because B was a integer kind of variable which was created and it was made to contain 78. So B technically didn't change. Now coming back to this list 1, let me append an element to this list. Let me append, say, add on to this list. So now your list 1 looks like this. Now this add on uh, now should not show up in list assign, since list assign was assigned list, or list assign was created before, like when list 1 did not have this element add on. So now let me check this list assign. List assign also contains this element add on. Now what is happening here? So literally this, what happens here is actually a reference list assign is created that refers to the same memory location as list 1. So practically no new memory was assigned to this. So this is technically not a list. List assign is just a reference that was made to list 1. Now if I just pop this element, the last element from list assign, so add-on was popped from list assign. Now if I try to find out what the elements in list 1, see, this add-on is not present. So whenever you make some changes to list assign, that will be reflected to list 1, and whatever changes you make to list 1 will be reflected on list assign. So this is not particularly what we are looking for, a copy variable. So for that reason, an element by element copy is needed, and that is done using the copy keyword. So another way of using this copy keyword is slicing. Like if I say list slice all equals to list 1, I use that braces and I add a colon, and now list slice all is this, and now I append an element to list slice all dot append, say add it. Now your list slice all looks like this using this add it. And now let's look at list 1. List 1 does not contain this add it element. So you can use this copy, or you can also use this as a what shall I say, as an alternative to copy. Okay, I think I didn't mention one more thing regarding this list slicing. Let me show you another interesting part. Or did I do that? Just a moment. Just allow me. Okay, no. Okay, I have done this list reverse. Okay, fine. Now let's move on to the next segment. Now here, so now so this phenomena. Okay, let me show you another thing. That is, let us consider this list number 4. So this was your list 4. Now let me try to make a copy of this list 4. So we can use either the copy keyword, or we can use this member by member copy using this indexing or slicing. So let's use the copy keyword. So list shallow, let me just name that as list shallow, and now list 4 dot copy, and now your list shallow looks like this. So now let's make some modifications to this list shallow, and it is not supposed to reflect your list 4 variable, right? So let's make some changes to list shallow. Let me change this 88. Sorry. This was let me change this. So I, in order to access 88, this will be done using the indexing, and this is index number 1, and I'm changing 88 to 23, and I will be changing this keyword IO. Now how to get to this word IO? Here, first of all, you will be accessing the element. Okay, before I do this change, let me show you something else. First of all, when you are when you're trying to find the number of elements in your list, you will be using the len keyword. So let me try out this len keyword with list 1, and it gives you 10, and list 1 contains 10 elements. So naturally you got this number 10. Now let me try this len keyword with list 4, and it returns 4, whereas the number of elements are 1, 2, 3, 4, 5. So instead of 5, you're getting 4. Why? Because actually what happens is, whenever you are trying this len keyword, len will return the number of elements at the topmost level. Here the topmost level is actually one dimension, and this entire sublist is considered as one element. So what happens here is, if you consider this as one element, this entire 90 and IO as one element, then the number of elements in your list is 1, 2, 3, 4. So that's how the len keyword works in this case. Now let's get back to modifying this list shallow. Now this was your list 4, and list shallow was this. Oops, there was a typo, so I got this error. This is your list shallow. Now let me modify some of the elements of list shallow. Let me modify this 88, that is element number 1, to 67, and I will also be modifying this element IO. So in order to get to this element IO, the indexing works like, first you will be considering the topmost element number. So the index number corresponding to this element number 4 is 3. This is 0, this is 1, this is 2, this is 3. And now, that is list shallow. So the first is the element number or the sublist number here, 3, and now you're getting inside the sublist, and inside the sublist the index of this element IO is 1. Therefore you will be writing 1, and hence let me change this IO to this keyword changed. Now, after making these changes, your list shallow now looks like this. 67, this was first change, that is at index number 1, and at this IO was changed to changed. Now let's look at how list 4 is doing now. Now this 88 remains 88 here, but look at this. This was supposed to be IO, but since I'll change that in list shallow, this also got changed in list 4. So this kind of phenomena is known as shallow copying, where the elements at the topmost level remain unchanged, but if there is an element, if there is a list kind of element, or if there is a nested element, actually what happens is a reference is created at that point, and if you make change in one list, that change will be reflected in the other list. Similarly, if I just change this list 4, say if I change 3 and 1, again changed, and now your list shallow See, it looks like this. Again changed. Now, in order to deal with this kind of problem, we will be using deep copying. And in order to use deep copying, we will be needing a library deep. So we will be importing the library deep. Sorry, importing library copy. Sorry. And now what we will be doing is list deep. Now we will be copying the same list 4, but we will be deep copying that. So that will be done using copy dot deep copy. And now I will be mentioning the name of this list, that is list 4. Now your list deep looks like this. And now I will be again changing this variable. List deep. This was element number 3 and index number 1, and changed in deep. So now your list deep looks like this. Changed in deep. This again was changed in deep. And now let's see what list 4 looks like. List 4 remains the same. So this again changed is not changed in deep. And now let's get back to the final segment of the list tutorial. So say now you have a list A, which, or let me just change the name, a list, let that be 23, 12 and 22. And now say you are trying to make another list that will contain squares of these elements. Now I'll first show you the traditional way of doing that. So let me mention a list square range, and this will be a blank list. Now I will be using the for loop here. So for I in range length of a list, so square equals to a list I into a list I, and square range dot append square. Now let me look at what your square range looks like. Your square range looks like this. But it seems like there are several ways of shortening this entire thing up. First of all, there's nothing wrong with using range and len, and there's nothing wrong with this. But if you ask me that if this code is efficient, well, I'll say no. First of all, you don't need these host of range function, then len function, and so on, because first of all, Python gives you a very easy way to iterate through the elements of a list. So here, let me change the same program once more. Say instead of I, let me use this keyword item. So you can always use I, there's no problem. I'm just changing this. That was my decision, of course. For item in, without using so many things, range, then len, you can write a list. So while I was retrieving the index value, here this piece of code retrieves each element in the list. So now your square, you don't have to use this index number. you can write, instead of a list I into a list I, you can write like item, item into item. And now your square range looks the same. But is it all? Well, if I say that you can do that, this thing, you can do that in just one line. And how is it done? Let me show you. Square one line. Okay, let me just, so this is your A list, and now I mention another list, square another. Now you'll start the braces of the normal list variable, then item into item for item in this was a list. So this entire thing, instead of square range, I'm using the square another. This entire thing is now converted into one line of code. Now if I show you what is square another, oops, sorry, I was trying to copy this. And this is your square another. See, you don't have to write so many lines. Of course, there was 1, 2, 3, 4 lines of code, and that is changed to one line of code. So what it does is, so this is your, what we did was, this was the first line which got shifted over here, and now this square equals to item into item, that is directly done over here. So these two lines are first written here, and then you mention the for loop over here. Similarly, if you have another list, say a B list, which is say 2, 3, 4. Now you want to make you want to compute a Cartesian product of B list with A list. What you will be doing is, instead of using so many lines of code, you can do that using just one line of code. So that is a prod list that equals to I into j for I in A list for j in B list. So now your prod list looks like this. And there is one more thing, this doesn't end here. Say from this prod list, let me say consider only those elements which are multiples of 4. Let me just I'll take those elements and I will save that in another list. So condition list, this is the list name of the list name, and now I for I in prod list if I modulus 4 equals to 0. Now let me show you condition list and see all the elements which are multiples of 4 are only selected in this condition list. This was your product list 46, so elements like 46, 69, these are not chosen in this list. So now this is all for today. This was all about list, the basic operations of list. I think I have mentioned everything. So here is a cheat sheet. There is one problem with this cheat sheet is here see extend, this won't be any value if you try to insert a value using extend, that will throw an error. So only a list can be added to this. So let me just edit it if I can. I think there's a problem with this now. Okay, so instead of that, whatever that was done in this class, I have given a synopsis of that. So you can just take a screenshot of this and you can keep that with you. So that was all for today. If you like to like me to do tutorials on other parts of Python, please leave me a comment, and happy coding. So goodbye for today. Meet you in another class.